Hello, today I'm making a short video about this circuit. I've designed this circuit for driving a flyback transformer. So with this circuit you can drive a flyback transformer. This circuit has one special thing. It has an audio input here, and so you can hear music by seeing the electric light arc that's coming out from the flyback transformer. Here we have the flyback transformer itself. This is from an old television. There comes out about 40,000 kilovolt or 40,000 volts. That's really much. So here we have the ground of the flyback transformer, and here we have flyback transformer. Okay, now I'm going to explain this circuit. Here, at first, this whole thing here is an non-inverting amplifier with an operational amplifier. You can see here. At first, we have the incoupling capacitor. This is the first capacitor. Then here we have these two resistors for the DC offset. You need to have about 10 kilo ohm resistors for doing that. That capacitor must have about 10 microfarad. Here we have the operational amplifier itself. I have used a LM741. With these two resistors you can adjust the amplification, or you can say what amplification you want to have. It's calculated by resistor 3 plus resistor 4 divided by resistor 4. So you have to play a bit around with these resistors to get the right amplification that you need. Here with this capacitor, this is for not amplifying the DC offset. Here we have the outcoupling capacitor. Here we have the driving circuit itself. It's built with an NE555 timer IC, and the frequency of this you can adjust with these two resistors and this capacitor. A good frequency for a flyback transformer is about between 5 and 20 kilohertz. So you have to play a bit around with these components to get the right frequency. Here at the output of this NE555 there is a power MOSFET. Must be a really high power MOSFET to driving the primary coil of the flyback transformer. Here you also need a power resistor with about 10 or 20 ohms. And of the NE555 there's coming out such a signal. So now for the music is coming in pin 5 and is frequency modulating the driving signal for the power amplifier, not power amplifier, for the flyback transformer. So you can play music with the light arc. Here I'm showing you the circuit. Here at first I have the power MOSFET, the power resistor, the NE555 and the LM741 operational amplifier. Okay, now at first I am showing you the circuit on the scope that you see what the circuit is doing. I have connected the second channel of the scope to the audio input, the really audio input, and the first channel of the scope I have connected to the driving output, to the signal output of the NE555. So now let's have a look to the signal output, and I'm switching on my power supply. So you can see the signal here. It's really important that it goes between 0 volts and the full voltage, and this is the signal that is going to the power MOSFET. Okay, so Now I take a function generator and put the input of the function generator to the circuit audio input. So now if I'm switching on the function generator, yes, you will see this. Okay, now the signal is frequency modulating by the function generator, but I'm putting in a sine wave. You can see here it's not triggered at the moment, so I'm triggering on the first channel, so this is going this way. And if I'm turning up the oscilloscope, you can see really good the frequency modulation that is going on here. Can you see it? The frequency of the sine wave is modulating the output signal of the NE555. Yes. Okay, that's it for the theory, and now I'm connecting the flyback transformer to this circuit. So, one moment. Okay, I'm back again. Now I have connected the flyback transformer to the output of my circuit. If you are lucky, you can find a data sheet on Google, and then you can see the pin out. Here, for example, the pin 3 on this flyback transformer goes to the resistor and 10 to ground, and the pin 1 goes to the switching transistor, and the pin 8 is the high voltage ground. Now I've connected it this way. So just Google the number that is on your flyback transformer if you want to find out how your flyback transformer is connected inside. So on the input of my circuit, I've connected this cassette recorder, and on this cassette recorder I've made a short voice recording, and now I'm going to play in the voice recording back with the electric light arc. So at first I'm switching on the flyback transformer, the circuit, and here you can see a small light arc. Ooh. Okay, and now I'm switching on the cassette recorder, and let's see what we can hear. So you have heard it, the voice recording is coming out from the cassette recorder to the circuit, and it's playing back by the light arc. That's no fake. I really like this. It's cool. Yes. Cassette recorder, line out, circuit, and the flyback transformer. So, okay. Now I'm doing other things, what you can do with a flyback transformer. So I'm switching off the light now that you can see this better. So now you can see the light arc when it is dark. I have put the two contacts a bit more away, and now I'm taking this neon lamp and put it to the near of this circuit. And you will see, beautiful, the neon lamp is lighting up just of the induced voltage that's induced into the neon light without any contact. If I put it away, you can see there's no contact and it lights up. So that's for the neon lamp. And now I'm switching on the light again. So now let's see how many energy is in this and what can it do to a paper. Here you can see it's burning. Have you seen it? There are many energy in this thing, so you can burn a paper with this. Smoking a bit. Yes, really powerful. Okay. Okay, for this experiment I've built an electroscope. This is an electroscope that's just made of alu foil, and here in the middle you have two plates of alu foil, and if I'm taking the high voltage plus and putting it up there, you can see it is going auseinander. You can see the high voltage is there, and there. So, okay, that's for the electroscope experiment. Okay, that's it for my flyback transformer things. So at the end I have to say it's really dangerous, so don't try it at home if you don't know what you are doing. So thanks for watching.